Okay, so sometimes we might have an equation like x over 2 plus 5 over 6 equals 3 over 4. So this is going to be my example. And we're like, oh, I don't want to deal with those fractions. Well, because it's an equation, we can multiply by whatever we want as long as it's on both sides, as long as it's not 0. And we could clear the fractions is what we say. Clear the fractions. And you do that by finding the LCD, least common denominator, and you multiply LCD on both sides. Okay? So in my little example here, if I look at the denominators, the 2, the 6, and the 4, and I think of the smallest number that they'll go into, my LCD is 12. So what I'm going to do is I'm going to multiply this side by 12, and I'm going to multiply this side by 12. And 12 is not 0, so I'm okay to do this. I can do that. And then the goal is to get all those denominators to cancel, then we won't have fractions and we can go back to solving it the way we're used to. Okay, now I don't usually write this step. What I usually write is I take the 12, the LCD, and I multiply it times each term. Okay, so here's the 12. You can put it over 1 if you want, but it's not necessary. And then I did the distributing already, okay? So I did 12 times this term, 12 times this term, 12 times this term. And then what's going to happen, because it's the LCD, all those denominators are going to cancel. 2 goes into 12 6 times, 6 goes into 12 2 times, and 4 goes into 12 3 times. So hopefully that all makes sense. But then what do you have left? Well, it's a big mess right now. So I have 6x plus, it's going to be 2 times 5, which is 10. And then over here I have 3 times 3, which is 9. So now I have this equation, 6x plus 10 equals 9. That's much more friendlier to work with, and I don't have to worry about the fractions anymore. So I just solve it the way I'm used to solving it. Subtract 10 from both sides. And divide by, oh, that's supposed to be -1. Got a little 0 happy there. Sorry. All right, so -1. And now I'm going to divide by 6. And so I get x equals -1/6. Okay, and you could check that. So here's an example. Again, this one's got an LCD of 12. Okay, but that's okay. The LCD is 12. And if you want to know how I'm getting that, I'm looking at the 4 and the 3. And what's the smallest number that they'll both go into? And it's 12. Okay, so here's how I'm going to write it. I'm going to write 12 times, and then I'm going to write this first term, x plus 2 over 4. Notice I put in the parentheses in the numerator. Okay, that was good. Then it's minus. Why is it minus? Because that's what's there. And then I'm going to have a 12. And then I'm going to have x minus 1 over 3 equals, and then sometimes people forget, you got to multiply both sides by the 12. So it's going to be 12 times 2. I don't have a fraction really on the right, but it still gets multiplied by 12. So each term, so those terms are separated by addition and subtraction signs. So I have stuff minus stuff equaling stuff. And each of those stuffs get multiplied by 12. Okay, now, that's the tricky part. Now here's the exciting part. 4 goes into 12 3 times. 3 goes into 12 4 times. And then over here, nothing cancels, but we'll just deal with that. So I have 3 times x plus 2 minus 4 times x minus 1 equals 24. And then I can solve from there. Now, some of you might say, oh, well, I didn't really want to write that step. I was going to distribute. Just make sure you're careful when it's subtraction, because that's got to be distributed. So you're going to have 3x plus 6 minus 4x plus 4 equals 24. And then I'm gathering my like terms. -x plus 10 equals 24. I'm subtracting 10. -x equals 14. And then I'm going to have to divide by -1 or multiply both sides by -1. I just divide by -1. X equals -14. So that's what I get, and I could check my answer and see if it works.